put this as a title because this is, it seems like in people's minds there's this permanent battle between the two. Which one is better? Honestly, this is really not, this is not the right question, really. To me, there is no, even this morning, funny thing is I was having breakfast and I had the question at the breakfast time asking me which one's better and which one should we use. It really depends. It really depends on the logic of your application. It really depends on what you're doing with your application. It really depends on what kind of constraints you're coding in. So to me, these are two different tools that are available in our environment. And so it's really up to you. I know this is going to be sounding disappointing to you because that's the subject of the question. But it's up to you to decide, really, not up to me to tell you which one to use. It's up to you to decide which tool you're going to choose to do a particular task, because both have their weaknesses, their strengths, and sometimes it even comes down to a simple fact that you are more comfortable with one than with another. Really, there are tasks where you need to do one simple thing, and you can do it with 4D, you can do it with SQL, and it's just, you know, if you don't have any other constraints, then sure, choose whichever one you're more comfortable with. One angle we can look at this question is the types of applications you guys do. So typically in a 4D client server environment, that's what we will do, the client server applications. I would break up those applications into three generic types. Now this is very generic and doesn't take into account a lot of details, but the first type is really the usual thing, okay, the usual suspect, the typical, your classical 4D client server application. You have your server that has the database with it, and you have all the data inside, and you have the full-blown client application that takes advantage of everything that 4D has to offer. You can always have a completely disconnected client. I'll explain what I mean. And then, of course, you can have something in between where you connect as a 4D client, but then how you access your data and actually where your data is actually not necessarily on 4D server. So let's go back to the first case. So the usual connected client, you can take advantage of all the magic that comes with 4D. All the APIs are there, your selections are there, automatic relations are there, forms, subforms. All that comes in a nicely wrapped package. You know all the APIs. You're very comfortable with it. But there's always a but. It's kind of heavy. You know it yourself. So when you have 10 clients, that's fine. When you have 100 clients, it's probably fine too. When you start having your installations that go over 2, 3, 4, maybe more hundreds of connected clients at the same time, and each of those clients is pretty heavy, you really need to start taking care of performance and memory optimization, and you look into cache, and because, as you well know, a client application, 4D client application, takes up a lot of resources on the server. And I'm not only talking about the CPU, I'm also talking about the memory, because every user process on the client will eventually trigger a new process on the server. So that consumes resources. And the second thing is, of course, is because every single one of those clients is related to one server, and by the nature of 4D protocol, the communication is pretty heavy between clients and the server. Now, if you're sitting with all those hundreds of clients on the local network, you're probably fine. But as soon as you have at least one client that's connecting from the outside, you probably know very well that every single slightest networking error will basically kill the client. You'll have this infamous dialog saying critical network error, and the only option you have is to click on OK and restart. The complete opposite of that is the completely disconnected client. Basically, it's not even a client in the sense of 4D. It's just a standalone 4D mono application, okay, that just happened to know how to talk to 4D server. And it happened to know how to get the data out of the server. And of course, the best way to get the data out of 4D server in that case is SQL. Okay, you can connect with the pass-through mode, and then you write your little begin and SQL in the code, and you talk to the server directly. Now, that thing is completely independent. So it really doesn't really matter how many processes you launch on the client side. It does not directly affect the performance of the server. You only load up the server when you hit it up with requests. So if you really want to unload the server and take it easy on it and have, I don't know, hundreds, maybe, I don't know, thousands of clients communicating, not connected, but communicating with the server, you can still do this with SQL. Of course, you can increase and scale the number of clients, but what you lose is that 4D magic, where you can no longer easily work with selections, because once you go SQL, you end up with arrays of data. You can no longer, as I said, you can no longer have this automatic access to all the beauty provided by 4D APIs, but you can still, to me personally, I think this is a really, it's a good price to pay for flexibility that comes with disconnected client. Because what you get is this real beauty. Once you stop connecting as a 4D client and you basically launch your standalone 4D application that talks to a server or maybe these servers, multiple servers, the networking becomes just almost a small inconvenience, because even if you have communication errors, in that case, the networking error is nothing else than, is nothing more than a regular error that you can catch with on error call. And even if you happen to be connected over SQL to a server, you send your request and you start reading data, and then an error happens. Well, that's fine, because that error will be treated like any other. The standalone application is not scared of networking errors. You'll catch that error in the on error call, and then you can handle it like any other error, which means, like, really of course, the real life solution will be much more complex, but the simplest way is just to simply, hey, there was an error, I don't care, I'll just reconnect and I'll resend my query, my SQL statement. So sort of this provides this, in that case, if you go the SQL way, you don't really need to be scared of networking problems anymore. So you have local network clients, that's fine. You have applications that are running on the internet, they can still connect to the 4D server and talk to it with SQL, okay? So as I said, you're going to have to write more code just because your data is in arrays, and you're going to have to write more code because some of the automation is gone. But once you're fully disconnected, you have this flexibility in terms of networking and handling when exactly you connect to the server and when exactly you spend server's resources, so you can scale easily. And we actually, Gary has a very nice example of his application where he basically does everything through SQL. Another advantage of this approach when you go, when you start using SQL to access the data is that you can have multiple data sources, really. Okay, so your data doesn't have to be on one 4D server. It can be on several 4D servers, actually several physical machines If you can manage to split up your application into multiple services, they can go ahead and live on different physical machines, which means you scale easily. In addition to that, if your clients ask for example, web access, okay, they want to be able to connect with a standalone application or go through a web page, or maybe they want to fire up a mobile phone application and connect to the server from there. You're gonna have to write SQL queries anyway to talk to the server. So once you're going that path, then the next logical step is, since I'm kind of writing SQL queries anyway, I might as well do the same thing in 4D, if only for code maintenance and code readability. If you have the same code throughout everywhere in all your code base, it's actually much easier to support such code. And then, of course, the third option is sort of a hybrid approach, where you mix and match 4D and SQL, and you use both. And again, I insist, this is not a war between technologies. This is not a war between toolkits. This is really deciding when is the right time and moment to use one or the other, and nothing actually forbids us from using both at the same time, just for different tasks within the same application. So when I say hybrid, what do I mean? Basically, for me, a hybrid application is a type of client that kind of still does connect to one. So I would say, I don't like the word central server, but it's a central server, if only, for example, for the purposes of authentication and a service discovery hub. Okay, I understand it's easier to imagine a case where we have one central entry point for all our users. So when such a client connects, we can verify who is this client, where is he coming from, what are his access rights, what he's allowed to do and what he's not allowed to do. And as you'll see later this week with other sessions, the other things we've done with single sign-on with the SSO, that also comes hand in hand with a hybrid client. And then, so yeah, that's the case of clients still connecting to the server, but only, it can be as easy, as simple as simply authenticating the client, okay? That 4D server doesn't even have to have any data in it, really. It's just a central point for the client to access to and figure out where the data is, which server, or servers, actually, multiple servers, what are their addresses, how the application can connect it. And then once you're connected, once you go actually once you need to do the actual work, display forms, do queries, display data to the user, accept some input from the user, modify the data, that doesn't have to really go to the central server. Okay, that can go through SQL, that can go to different servers sitting on the network. And then again, however you plan to split up that data between multiple services, that totally depends. There's no common solution, okay? Some indications can be just logical blocks within the application, okay? Some things just easily separatable and you can take them out onto a separate server. Some things are separatable because for geographical reasons. If you have multiple offices in different regions, different countries, it totally makes sense to run one central server that will accept connections from all the users, but then the actual data access will go to the regional server, because most of the time people working with the data in one country, 99% of the time it will probably work with their local data, and only occasionally will need to go to outside servers. So yeah, again, in that case, you have more work to do because data is spread out over multiple servers and multiple services. So there is more coding involved, but you're paying this price to have this greater flexibility and the ability to have more clients connected to to the server. Okay, so see, so far I haven't told you which one is better. So far I haven't pushed you to one or the other. I'm just laying out all the possibilities, what you can do with those. And again, I kind of have to insist that it's going to be up to you to decide when and where to use them. But the thing is, since there's no this pre-packaged answer, which one's better and which one you need to use in which case, in order to make the right decision, you kind of have to explore both languages, 4D and SQL, and I assume you know 4D pretty well. So don't be afraid that's like when I learn new languages, that's usually what I do is whenever I have a certain task to implement, to perform, to do, the immediate answer is, hey, I know that this task I can do best with this particular tool. But I kind of force myself, no, Sergey, come down. I know I can do this in 5 minutes with this tool or this toolkit. But I kind of force myself to say, well, I kind of have to learn this other language, so I'll go ahead and do this particular task with that other language. Even though I know it's going to cost me more in time, and I know it's going to be frustrating because probably I'll spend some time looking at some obvious things without knowing how to do them. It's frustrating, I understand. But later on, it will help me a lot to make the right decision when I'm actually working on some complex task with some important consequences. So that's why I want to talk about dynamic queries because, well, even in 4D, okay, 4D provides tons of APIs to do whatever you want with the data, okay? And when we start coding, we have, I don't know, be it 4D or be it SQL, we do one simple request, okay? We need to get the data. Then we need to maybe filter the data. Once we do this, the first step works. We see the data on the form. This is really nice. But of course, then pretty much every single time we figure out, well, I kind of did the filtering, but the thing is hard-coded, okay, in my code. And it doesn't matter, 4D or SQL, it's hard-coded in the text of my method. So I'm starting to add parameters, okay? If I want to filter by city name, I will never hard-code city equal Paris, okay? I will need to provide a parameter. So little by little, my filters will become parameterized, so to speak. Then, of course, I have this. It's no longer sort of a query. It's a pattern that I want to apply to a table. The next logical question is, since I have this query already with parameters, I kind of want to apply the same query maybe to multiple tables. So if I'm typing in SQL, the next logical question is, the next logical step is to parameterize the actual table names and field names so that I can apply the same pattern to different patterns query to different tables. And we do the same thing in 4D because once we realize that this query kind of works on multiple tables and I don't know which one I will use, which one the clients will use, we start using pointers to tables. We start using pointer variables. And so little by little, the code becomes a bit more complex than the simple few lines of code we started with. And that code tends to spread out over multiple methods. And so we have this whole infrastructure with nested method calls where we little by little we build our application logic and we build this powerful pattern query that we can run almost against any table with lots of parameters. And why am I talking about this? I'm talking about this because I noticed that me personally, and then internally with my colleagues, I find it actually easier when I debug and when I trace the code. I find it personally, again, this is a personal preference, but I find it easier to work with SQL in that particular case because when I step through the code, I can see that little string, because SQL query is just a string, really. Okay, I find it easier to see that string grow little by little when it's been constructed dynamically. But the most important part is once I get to the point where the query is built and I'm ready to run it, the huge advantage to me is that I just see it on the screen. Okay, I just see this whole thing that will select certain things, that will filter on certain conditions, that will sort on certain fields again or expressions, and then eventually do some other constraints and limitations on my data. And it seems like a simple thing, and lots of people discard it when I mention it. But honestly, when I have to work on it day in, day out, this is enormous. This is really important to me, because I step through the code, and when I get to my execute command, I see what I'm doing. I see the exact manipulations that will happen to the data. What's so different with when you do the same thing? So you can do the same thing with 3D language, right? You can filter, you can sort, you can limit data in other ways, you can group it. It's all split up over multiple lines of code. And it's really, the difference is very subtle. The code in both cases, 4D and SQL, it does exactly the same thing. Okay? In the end, we're going to end up with exactly the same data. Okay? It's just the way, the path we get to that data is very different. What I find slightly less intuitive when I do the same thing in 4D is that I have to make this, always have to make this mental effort to keep in mind what is the state of my data, what is the state of my current selections, especially if I'm working on multiple tables. What kind of filter did I apply just 5 calls ago to one table, and is my data still sorted on that other table, and how am I merging the results? It's not a big deal when you're really coding it right now, because everything is like mentally, you have the picture of the application, that's fine. But if you have to revisit that code 6 months ago, or maybe 1 year ago, 6 months later, or 1 year later, you kind of have to relearn and remember everything you've done before and the logic that's behind that code and what you do to all those tables in those multiple method calls. So here, if I really have to compare 4D and SQL, I would say I'm personally much more comfortable when I end up with SQL queries as a result, because in that case, I don't necessarily care that much how the pattern, how my data manipulation was prepared for me, because whatever I did before, multiple steps that I have to do to prepare the execution of my request, right before the execution of my request, I actually have it. I have it on hand, that request. And SQL, the nature of SQL is that it's very, very compact. It's very easy to read, very easy to understand. It's pretty much, it uses the English keywords, really. So when we need to sort, we do order by. When we need to filter, we say where, and then we spell out the filter in very, it's basically a human readable expression. We compare fields to certain values. We do and, or, not. So it's very intuitive, and I find it very easy. I find it much easier in that case to use SQL than 4D language. And what I actually suggest to my colleagues is if you feel you're more comfortable with 4D, that's perfect. That's not a problem at all. But what I'm suggesting is that because SQL is so short and so easy to write, and it does so many things just by a few lines of code, what I usually suggest is that it can be a great prototyping and debugging tool. Okay, prototyping, because that's usually what I do. No matter if I don't care if I need to create my form in 4D or SQL or whatever I need to display on that form, the very first iteration of my implementation is always I just do a whole bunch of SQL statements. It's not maybe it's not pretty on the screen. I'm not a great designer in terms of interface, but if I know that I need to display this data from those 2-3 tables, and I need to be able to navigate, I'll just write a simple select statement, pull the data out of one or multiple tables, and I use select into list box, okay? And in a few lines of code, I'll have the data on the screen. Now, and I do this even if I know that later on I'm going to have to rewrite it, maybe with 4D for whatever reason. It's still, I find it personally that if I launch, from the moment I double-click on 4D binary to the moment where I have a form that displays the data I need to look at, I write at that point much faster with SQL than 4D. So another advantage, of course, because in the beginning I kind of talked about the fact that we can run multiple servers serving 4D data. The huge advantage of SQL in that case is that once the query is prepared, once I have my pattern with all the parameters and everything, I don't really care against which server I'm going to execute that query. Okay? So if you have multiple servers serving data, and some of them even are not 4D, some of them are SQL compatible, then the choice actually is not that difficult. Since you know you're going to be talking to multiple servers, and some of them not 4D, you're going to end up writing SQL queries. So, and as I say at every single session, I'm kind of lazy. I don't like to do things that are not necessary. If I see that I will end up writing SQL queries anyway, then I'll streamline my logic within the application in such a way that basically everything's SQL. It'll be more compact. I'm not going to have to mix and match 4D and SQL code, and I'll go that way. Kind of sounds perfect, but it's of course there are some hidden problems in that approach. And one thing about SQL, as I said, it's one shot. Okay, you get your final query before executing it. You see exactly what kind of data you're going to get. But sometimes that can be a disadvantage because it is one shot. Okay, imagine I need to get some data. I need to apply some filters. I need to sort it. I need to group it, and then I need to limit it. So these are multiple steps. I describe them using SQL, but they're all done at once. Okay. Problem here is if my filter, if I have a lot of data and my filter takes 1, 2, 3 seconds, then every time I need to modify a small parameter, I actually need to rerun the whole query. Okay. And if the data was sorted, I need to resort it again. So when the user is presented with the data, with the form on the screen, and he clicks on a button, if there is a lot of data behind that button, and there is a lot of filtering, every single click will actually trigger the whole thing from start. You're going to select the data, you're going to filter it, you're going to order it, and do some other manipulations to it. Now, in that case, 4D can actually be much more useful because in 4D it's much more fine-grained. You cannot just say at once, okay, DB4D server, please select, filter, sort, and do some other stuff. No, you always do it step by step. So first, if you need to do a filter, you prepare your selection. Basically, you basically do a query against 4D server to prepare your selection. Once your selection is ready in 4D, then it's up to you to decide, do you want to sort it? Or actually, you can say, well, I did this filter, but the filter returned 200,000 records. I don't even need that much data, really. First, I want to refine my filter, okay? So you maybe add some additional conditions to that filter to produce less records. And then maybe you go down from 200 to 100,000 records, but that's still a lot. So you can apply another filter. So you end up maybe with a few thousand records, which is fine for display. And only then you can say, okay, now I have 2,000 to 3,000 records. Now I can sort it. So you do whatever sorting commands you need to do in 4D, and you end up with sorted data. But then you realize, or maybe the client realizes when he uses the the end user realizes that, oh, I didn't sort on the right field. I need to sort on some other field. So, but that's not a problem because you already have that small selection of 3,000-4,000 records, right? So if you want to sort on another field or even an expression, it's going to be really fast because you're going to be sorting that small filtered data. And here 4D wins, obviously, in that particular case, because if you would do the same thing with SQL, there is no way in 4D SQL to say, hey, I won't have this filter, right? But I'm not sure what I'm going to do with it. Maybe I'll sort later, or maybe I will limit it later. That's not how SQL works. SQL does everything at once. You build the whole query and you run it. So in that case, if that's why I insisted from the very beginning, there is no right answer. If the logic of your application is such that you don't really know how the end user will manipulate the data, okay? And by the nature of your forms, the data is kind of exposed for whatever manipulations user wants to do to it, then maybe 4D language will be the better choice in that particular case because you'll save time. You will not need to rerun the same similar query over and over again with SQL. Instead, you can do it 4D way, prepare the selection, and then manipulate, reduce it more, and then manipulate it on the client side. So it's really up to you to see what fits best in the particular logic of that particular application, and maybe even in the logic of that particular form, because even internally, I've seen our applications where two forms are displayed. They look kind of similar, but I know behind the screen they do different things, and so I know one is actually written purely in 4D, and then the other manipulates data with arrays and SQL, even though the forms sort of resemble each other. So it really depends, and it all happens within the same application. Another thing that kind of sets apart SQL from 4D is, from my point of view, how expressive SQL is. You can write, I don't know, 5, 6, 7 lines of SQL code, okay, and it will do so much more than the same code you would have to write in 4D. It's just a matter, I'm lazy. It's just a matter of typing on, pressing the keyboard buttons. And as I said before, just this visual cue from the query that comes when you see the whole query on the screen. To me, this is a great help because I know exactly how my data will be manipulated. The SQL also flows naturally when it's presented on the screen. And instead of just talking, I can show you the small screenshot of the code I had. I was preparing for the summit. So this is actually the screenshot. That's how it looks in 4D method. You type your SQL queries inside begin and end SQL block. So if you look at that query, it only has like 4 lines of text, really. It's not even code. When I talk about SQL, I prefer to use the word text because code is too strict. It's text. So what am I really doing just to dissect that query into small parts? Now I'm taking 2 tables here, customers and cities, and I'm asking the database to join the database between those 2 tables. Okay, this is just 1 line of text, and I'm providing the condition on which it will be joined. In that case, it's pretty simple. I'm just comparing city IDs. Okay. And if I happen to want to add another table, I want to add a 3rd table, I'll just, it's another line of text on the screen with another condition, okay? And if I wanted to add 4th or 5th table, it will be as simple as just adding lines to my query, okay? Then, of course, I also say this is how I want to filter my data because I don't need everything. I need data that satisfies certain conditions. If I wanted to eventually sort my data, again, it's all with it kind of grows within the same block. It flows naturally. I say what tables I'm using, then I say what are my filters, then I'm saying how I'm going to sort my data. I'm still on the same page. Okay, I'm still within my 4 or 5 lines. And then, of course, I can also limit the data. I can say I only need like 10 records. I don't need everything. Okay, this is kind of a difficult subject. Another thing where, like in the very beginning, where when I was just we released SQL Engine in V11, this was probably my go-to response to the question is, okay, Sergey, which one? Just tell me right now, which one should I use? Should I use 40 or should I use SQL? I would always go and say, hey, have you seen how simple it is to do joins, like inner joins and external joins in SQL? Because, sure, even with 4D, I'm not saying it is impossible to deal with 4D. And it's actually possible. It's quite easy, okay? And even external joins, actually, we can do with 4D too, because we have our automatic correlations between 4D tables, okay? So just a few words on external joins and what are those. External joins are a way to match the data between 2 more tables, okay? But usually when we activate our 4D relations, or when we do internal joins, we only see the data that actually matches between 2 or 3 or 4 tables. The data that doesn't match, it's actually filtered out. So a simple example, I don't know, you have a table of employees and a table of departments, okay? And a table of the employees, for each employee record, you have a department ID, and that means the department in which that employee works. So if I want to know which employee works for what department, I basically do a join between the 2 tables, and so that will result in a simple display of employee name and right next to it department name. So I'll know who works where, which is very nice. Now the problem is, what if there is a new department that's been created just yesterday and no one has been assigned to it yet? Okay, in that query, that department will never appear. Or let's say a person quits, or a new person gets hired, or a person gets transferred between departments, and temporarily he's assigned a non-existent department ID. Okay, or just department ID in his case is null, and it's just not assigned at all. When we do an inner join, that employee will never show up actually in the list of employees. So we will miss the data. We will miss certain people. We will miss certain department from the display. And that's where external joins come in. It's the ability basically to say, please join the tables and show me all the matches, but also show me everything that didn't match at all. And so if it didn't match, if the employee doesn't have a valid department ID assigned, in that case, the employee name is still returned in the results. It's just that anything related to the department will be filled out with nulls. Okay, so you will never miss the data. You'll always see the data displayed. And so whenever someone would ask me when we were just starting doing SQL in 4D, so what is the greatest advantage of SQL in 4D? So why would you suggest me to use SQL? That would be my go-to response. I would say, hey, have you seen how easy it is to see the data that's hidden, the data that doesn't match? Just use external joins. But then, of course, my colleagues would say, no, but Sergey, come on, we can do external joins with 4D because all you need to do, you need to activate an automatic relation between 2 tables, right? And then when you look at the current record on the left, if you have something on the right, then there is a match and you have all your matches. But if you advance to the next record and the automatic relation is activated, but there is no current record on the right table, it means there is no match, okay? So this basically means, in our case, this is an employee that doesn't have a department ID assigned. So it's easy to do it in 4D too. But I still have to insist, sure, it's easy, but you need to write loops, okay? You need to actually loop through the data, and you'll need to look at different conditions. Do you have a current record, or don't you have a current? If the current record is there, everything's fine. If it's not there, it's not a match. If you have more than 2 tables to join, that actually becomes more of a problem because you add additional loops. If you have 3, 4, 5 tables to join and you want to see everything that doesn't match, then you increase the number of those loops. And that's kind of, and I mean, I saw developers do that, but this is a kind of code that's just simply not fun to write. Okay, this is some routine code that you need to churn out and you need to write it. There is nothing really intellectually interesting about writing that code. It's just some loops with matching, if, else, conditioning. It's kind of boring a little. And since I'm lazy, whenever I see something boring, I'm looking for things that I can do differently. And in that case, I think SQL wins clearly. But again, not necessarily always, because again, don't forget that SQL is one shot. Okay, you tell it to do one thing, it will do it, but it will do it all at once. And the greatest advantage of 4D here is that it doesn't really do everything at once. Because in that case, if you need to match 2 tables with automatic correlation, and you need to loop through the table to see if there are any matches or non-matches, then you can actually stop at any point. The thing is, what if you're looking for just the first thing that doesn't match? Okay, you have thousands and hundreds of thousands, millions of records in a table, but you're looking for the first one that doesn't match. Okay, you're writing your loop, and the perfect thing here is that you will stop the loop from iterating as soon as you find the first non-match. So you'll break out of that loop, you'll continue with your 4D code. It will be really fast. The problem with SQL in that case is it'll match everything. It will join everything. So if you have a huge table of several 100,000 records or millions of records, there is no way to tell to SQL, listen, I'm kind of looking for non-matches, but give me just the one, okay, or the first 2, the first 3. You cannot do that. You're going to have to run the whole query, and if you happen to have a large data set as a result, that's what you want to. That's what you're going to get. You will not be able to stop, basically, in the middle of the execution. So this is one of the things to keep in mind with the subtle difference between 4D and SQL. Even though in that case, like you saw the query before, the query will be very short, but you will end up executing that query at once. You will not be able to break out of it. Just a couple of words on joins. One of my latest projects is that we actually we re-implemented completely external joins in 4D in V15 R something, R4 or 5. I don't remember exactly. But if you take the latest version of 4D, nothing has changed structurally. Okay, you can still run those external joins as before. It's just that we added some new functionality, and they are optimized very well, so they're really fast. So whenever you get a chance to try them out, I would highly recommend. Just a few words on data structure. One of my go-to responses to question comparing 4D to SQL is the access to the data structure. Okay, this is not a question which one's better, which one's worse, which one wins. Really, because there is no competition. You cannot easily modify the data structure with 4D language. Okay, you can only do this with SQL, so it's a no-brainer. Whenever you need to create tables to I don't know, delete indexes or create views or modify the structure of existing tables, the only way to do it is through SQL. So not much choice. But you have to keep in mind one of the problems you guys started experiencing with modifying data structure with SQL is that twofold actually. If you delete, create tables, you're going to start having holes in table numbers, and we're not used to that. Okay, we know that if we start looping from 1 to n, we're going to access all the tables from 1 to n. No longer with SQL. If you drop and create a new table, you risk having holes in your table numbers. It might happen that you have tables 1 to 3, But table 4 doesn't exist anymore because it was deleted. And it used to be very convenient to write loops that access tables by their numbers. You need to be careful. If you allow to delete or modify data structure, you may end up with those holes. Another problem, actually pretty big problem, some of you guys let the end users modify the data structure to their liking for whatever reasons. Maybe they need to store extra data. Maybe they're smart enough to add additional services to their applications. Once you give this power to the end user, the version upgrade kind of becomes a smallish nightmare, to be honest, because you can no longer simply copy and paste the new data structure file to replace the old one, because you will actually lose whatever structure modifications the client, the end user did while you were working on the next version of your application. So the extra care, if you allow the end user to modify the structure, be sure to before actually migrating to the next version of the application, to export whatever changes were done, and then upgrade the structure, and then import the modifications back. So that's something to keep in mind. Another thing that's kind of useful, and it comes only with SQL, is a little known command, use database. How many people here, just raise your hand if you ever had to use the use database command? No? Okay, one. Nice. One. There's a second hand there, too. It's basically a way, it's a small command. It's documented, but we talk about it every summit, but I'm having trouble convincing people using it as much as I would like. It's basically a small window to another 4D database that sits locally on your machine, okay? So you have your 4D server running, you have your database, your main database. But if for whatever reason you happen to want to store data externally, okay, you don't actually need to write it to text file. You don't need to write it some other data source. You basically can create an external 4D database, okay, and write to that database. And you can write, I don't know, logs, user activity. You can back up some critical data. You can externalize some auditing, for example. You can store whatever security information or security-related information. Anything that you don't really need to store within the application itself can go to that outside local database. And the huge advantage is that it's a 4D database, okay? It's not a text file that you need to analyze later. It's a 4D database. You just, whenever you need to analyze it, you open it up in 4D. You can add indexes, you can add interface, and you can actually analyze whatever data you stored outside of the application. So it's really useful, and there is no other way to do it other than SQL. Okay, so this part I really have to talk, even though we have 3-4 minutes left. So 4D stands for fourth dimension, okay? We should rename it to 5D, actually, because since we've added views in V12, I think, or 12, V30, I don't remember, 12, I think. In the end of the V12, we've added views. To me, this is pretty much a fifth dimension to your data, because you know pretty well that 4D is a two-dimensional relational database. So most of the time, the data is very well structured and normalized to avoid redundancy, to avoid extra copies of your data. So we normalize the tables. But the more tables are normalized, the farther they're away from the actual application logic, okay? You have city codes in one table, city names in another table, client codes in another table, client names in another table, and data is spread out. It's normalized. It's perfect. There is no duplicates. It's awesome. From the point of view of data structure, it's great. But when you need to access it, you end up writing relations and joins and conditions and filters, and you do them over and over again. And that's why I'm saying views are pretty much fifth dimension to fourth dimension database, because you can aggregate the data back to its original form using SQL views. With views, you can really work with the data that matches perfectly the business objects of your application, really. Okay? And there is really, you can sort of simulate it with a lot of work and with a lot of effort. You can do it in 4D, but when you do views, it has zero impact on performance, and it actually creates like a sort of a virtual tables for you. I've never really replied to the question which one's better and which one wins and when should you use one, when should you use another. What I'm trying to say is really learn both, and then in each particular case, see what kind of restrictions you have on your application logic, and then just see which one suits you better in terms of performance, in terms of code maintenance, in terms of scalability of your application, and go from there. But to be honest, I've seen applications done purely in 4D. I've seen applications done purely in SQL, spreading over multiple servers, and both types of applications work perfectly well. So you can do anything and everything with SQL, and you can do anything and everything with 4D. So it's only a choice of choosing. It's just a matter of choosing the right tool for the current task. There you go. Thank you.